fire. It's really cool. Wait, no. I'm just saying it's solid. It's not solid. Fire is interesting. So today we're going to be conducting the flame wait, can you see that? Flame MEL science experiment. 10 plus for some reason. Drink one was 12 plus. Alright, let's open this. Okay. Oh yeah. Okay. This now. Welcome to science. Smells the same. Nothing. Okay. We have 3 experiments in this one. Burning magnesium, green sparkles, and rocket fuel. So all 2 of these are danger 3 out of 3. One of them is danger 2 out of 3. Green sparkles. We're gonna do this one today. Yeah, green sparkles. That thing. See it? Okay. Copper ions turn into a flame. Copper ions turn a flame green. Difficulty 2 out of 2. Danger 2 out of 2. Duration 10 minutes. Safety. Put on protective gloves and eyewear. Conduct the experiment on the tray. Keep a bowl of water ready during the experiment. Keep hair and flammable objects away from flame. Disposal. Dispose of the regular experiment residues along with regular household trash. Cool. Alright. Right, eyewear. About that. One moment. Oh, this was literally 2 feet away from me. Never mind. Okay. Conduct the experiment on the tray. Hey, Dad?
Yes.
Would you do me a favor?
Yes.
Why, thank you. Alright. Green sparkles. How do we do this? 1, melt some paraffin. Oh. Well, what do you need? Of course we need the beaker. Fun fact, we had our beaker until about an hour ago, where it's gone. What a plastic beaker. I'm just gonna say it's fine. Okay. Put water, wait, I need a bowl of water. One moment. Okay, this is about halfway full. Melt some paraffin. I'm gonna light my lighter. Okay, get this here. I'm gonna move this thing off of the tray so you can actually see this. Perfect. Kind of. There. Odd. Oh wait, I forgot. New camera. I can do this. You can't see that, can you? So I'll do that. There we go. Go. That's beautiful. Okay. What's next? Wait for 3 minutes, of course. Okay, what's next? I'm gonna put this here. Maybe I could speed up the process. This is a bad idea. Don't do that. Wait, you can't see that. This is a bad idea, kids. This is to do this. Okay, and now we have some melted paraffin. 2. The copper sulfate Cuso 4 crystals will stick. I'm just gonna call it Cuso. Stick to the paraffin. Okay, got this. So dip this into the paraffin. Cool. Then dip it in here for 30 seconds. Alright, 30 seconds has passed. Now we're going to dip it back into the paraffin. And we can use water to cool the outer layer. Now we have this. This. Would you look at that? It was green for a while. Come back. How does it smell familiar? Well, why not do it again? That was pretty short. Huh. The stick appears to be burning. I kinda just wanna let it burn. Okay, enough of that. This is getting boring. Faster! They're losing their patience. Look at them. Now. Sure, it's fine. Okay, next experiment, because that was pretty easy. Or should we do it? I'm gonna do it again. So what's happening here? Green sparkles. Have you ever wondered how fireworks are made to sparkle with all sorts of colors like green, red, or pink? The experiment you just performed might give you some valuable clues. Of course, you can't simply paint a flame with a colored substance. Black coal, brown wood, and white paper all burn with the same yellowish flame. Even in this experiment, your blue copper sulfate tinted the flames green, not blue. However, there's certainly something to this copper sulfate compound that made the flame green. And this something is its copper ingredient component. As it turns out, metal ions such as copper ions can emit light of a certain color when heated to high temperatures. Copper emits green, while rubidium, Rb, creates red, and sodium, Na, which is present in table salt, somewhere, creates red, no, yellow, and so on. In addition to entertaining others with colorful fireworks, chemists use this property of metals to detect which metal is present in a sample by carefully examining the color of the flame using special tools. In fact, every element in the periodic table has a characteristic light fingerprint that is visible under certain conditions. One chemical element was cunning enough to evade chemists' attention on Earth, but couldn't hide its light fingerprint in the light of the sun. Nowadays, this element often attends parties in a balloon costume, and its name is helium. Cool. Next experiment time. Next experiment, because this is getting boring. Put these little crumbs aside. Okay. What's next? Burning magnesium. Danger 3 out of 3, duration 10 minutes. Magnesium burns brightly in air. We're going to use magnesium. This is amazing. Safety. Put on protective... Oh, wait, I forgot my gloves. But we didn't need gloves for the last one, did we? Huh. Well, I'm just going to pretend like that didn't happen. Burning magnesium. Conduct the experiment on the tray. Take protective gloves off before lighting the candle, of course. Handle magnesium only with clean and dry hands. Wait until magnesium burns out completely before disposing of it. Keep hair and flammable objects away from the flame. Okay, here we go. Oh, fancy. Oh, we're using the stove. Let's go. So, we have this fun little thing. There you are. Okay. Okay. I hope this is foil. Now we need a big spoon of hexamethylene tetramine. I'm gonna memorize these one day. Alright. Here we are. Place the wire exactly as shown. Read this. That goes there. This goes here. I think. Yes. Yes. Wait. Yes. Okay. Now we need to take here. No, wait. What do we need? Ah, yes, of course. Magnesium steel. But where? I'm gonna time lapse this. I'm so interesting. It's right here. And then you place it right here. See? Oh, wonderful. Initiate the reaction. So, take off these gloves. Super resistant to stick. Okay. Light the splint. Okay. Here we go. Light the solid fuel. This is gonna be really bright. How bright is it gonna be? Oh, that's bright. Oh, that's really bright. Oh, that's actually pretty bright.
So what are we watching here? What's the process?
So, picture a metal. Take a second to examine it in your mind's eye. Do you think of something strong and reliable and relatively non-flammable like iron or copper?
Okay.
Actually, most of the elements in the periodic table are metals and can have all sorts of different properties. Many of them burn no worse than magnesium.
Yeah, that's mine.
From a chemistry perspective, burning is the process of giving electrons to oxygen in the air and releasing a lot of heat and light. One of the obvious trends in the periodic table is that the elements on the left side of the table are generally more willing to give electrons away than the ones on the right. Burning magnesium. More familiar metals such as iron and copper are in the middle of the table and are generally not overeager to give oxygen their electrons. Since magnesium sits fairly near the left edge of the table, we can predict it readily gives some of its electrons to oxygen. And it does, turning into a new compound, magnesium oxide, MgO. Meanwhile, the elements of the very left edge, such as sodium and A, potassium, K, or cesium, cesium, do not even need a lot of heat to start reacting with oxygen. They'll ignite easily or even spontaneously just when brought into contact with air. You may not have realized, but you probably encounter extremely active metals such as sodium quite often. Not just as metals, but within compounds. For example, sodium chloride is just table salt. Magnesium, in turn, is an essential component of chlorophyll, the compound that makes plants green and allows them to absorb sunlight.